Welcome to Kubernetes, from chaos to control, a clear, no-fluff guide to understanding the world's leading container orchestrator. Today, we're taking everything on these slides and turning it into a simple, powerful story that you can finally make sense of. So let's go from confusion to clarity. Before Kubernetes existed, deploying applications was honestly a painful, fragile, messy process. Everything relied on manual server management, installing dependencies the hard way, and constantly monitoring to make sure things didn't break. And sure, containers like Docker helped by giving us lightweight portable environments. But containers introduced a brand new challenge of their own. Now, we weren't managing 5 or 10 environments. We were managing hundreds or thousands. Suddenly, new problems appeared everywhere. Where do all these containers actually run? What happens if one of the servers hosting them crashes? How do we handle sudden traffic spikes without everything falling over? And how do we roll out updates without causing downtime and angry users? This was the world before Kubernetes, a world filled with questions, but not many answers. Then Kubernetes came along, acting like an autonomous orchestration engine. Its job is simple: bring order and sanity to containerized applications. Kubernetes schedules your containers across a fleet of machines. It scales them automatically to meet demand, and it heals them by restarting or replacing them when they fail. It transforms all of your infrastructure into a single, robust, programmable resource. Instead of manually controlling every moving part, you tell Kubernetes what you want, and it makes it happen. Now let's look at the foundation of everything, the Kubernetes cluster. At the center of it all, you have the master node, also known as the control plane. This is the brain of the entire system. It makes all the global decisions for your cluster, scheduling, monitoring, and responding to different events. Then you have the worker nodes. These are the muscle. These machines are where your applications actually run as containers. The brain decides, the muscle executes. Together, they form a coordinated self-managing system. Next is the smallest deployable unit in all of Kubernetes, the pod. A pod is a wrapper around one or more containers. It shares networking and storage resources, and every container inside a pod runs on the same worker node. The key insight is this: pods behave as a single logical unit. If one container within a pod needs to talk to another, they share space. Kubernetes doesn't move containers within a pod independently. The pod moves as one. Now let's talk about deployments. The blueprint that tells Kubernetes exactly what to run and how to maintain it. You simply declare something like, run this app and keep 3 pods alive at all times. If Kubernetes detects a failure, maybe a pod crashes, the deployment controller immediately replaces it with a new one. It restores the desired state automatically. This is Kubernetes self-healing in action. You no longer worry about individual failures. Kubernetes ensures that the system always returns to the state you described. Pods are temporary. They come and go. Their internal IP addresses change constantly. So how can other applications reliably connect to them? That's where services come in. A service provides a single, stable IP address and DNS name for a group of pods. It acts as an internal load balancer, routing traffic to any of the healthy pods that are part of the deployment. You have different key types: cluster IP for internal access, node port for basic external access, and load balancer for exposing the application to the outside world. Services create a reliable surface area for communication, even though pods underneath are constantly changing. Now let's extend that idea to external traffic. Ingress is the smart traffic controller for your cluster. It manages external HTTP and HTTPS traffic and routes it to the correct internal services. With Ingress, you can use domain-based routing, like api.myapp.com going to your API service. You can use path-based routing, such as myapp.com/video going to a video service. And you can handle TLS termination, managing certificates in one place. Ingress gives Kubernetes the ability to expose multiple services cleanly, all behind one unified entry point. Kubernetes has two major superpowers that completely change how systems operate: autoscaling and self-healing. Autoscaling automatically adjusts the number of pods based on real-time demand. It can react to CPU usage, memory usage, or even custom metrics like requests per second. If traffic increases, more pods come online. When demand falls, pods scale down. Self-healing is where Kubernetes shines. If a pod crashes, it restarts. If an application becomes unhealthy, Kubernetes replaces it. If a worker node goes offline, Kubernetes reschedules its workloads onto other healthy nodes. These superpowers make your system not just scalable, but truly resilient. Now, here's the real magic of Kubernetes. You don't tell Kubernetes how to do something. You simply declare the desired state you want. Step 1. You write a YAML file describing that state. Step 2. Kubernetes continuously compares that state with what's currently running. Step 3. The control plane takes action, reconciling any differences. You describe the destination. Kubernetes figures out the journey. Let's look at where Kubernetes really shines out in the world. Microservices, deploying and scaling dozens of independent components like Netflix or Spotify. Machine learning, managing training pipelines, GPU workloads, and automated hyperparameter tuning. Event-driven systems, scaling workers, and queue consumers based on demand. DevOps and CI/CD, powering automated pipelines that build, test, and deploy code directly into clusters. Cloud-native applications, running consistently across any environment. Public cloud, hybrid, or even on-prem. These are the real-world scenarios where Kubernetes truly becomes the backbone of modern infrastructure. If you want to master Kubernetes, here's the clear roadmap laid out in the slides. Start with the foundation. Understand containers first and master Docker basics. Learn the core objects: pod, deployment, and service. Practice locally using Minikube or Kind. Deploy a real application of your choice and containerize it. Add advanced features like autoscaling, health checks, config maps, and secrets. Expose your app externally using Ingress. And finally, move to the cloud by graduating to a managed Kubernetes service like AWS EKS, Google GKE, or Azure AKS. Follow these steps and you'll build a strong practical understanding of Kubernetes. Today, based strictly on what's in these slides, you gained a brand new mental model for Kubernetes. You learned the problems Kubernetes solves, the chaos of managing containers at scale. You learned the core architecture, the building blocks that create stability and control. You saw how the declarative model works, the magic behind how Kubernetes keeps everything running the way you want. You saw why Kubernetes is the backbone of the modern internet. And you now have a clear path for how to continue your learning journey. Kubernetes is no longer a confusing buzzword. It's structured, it's manageable, and it's a powerful tool for building the next generation of applications.
If this helped you gain clarity, make sure to hit the like button so more people can find this breakdown. Subscribe for more simplified tech guides and drop a comment telling me which topic from these slides you want to go deeper into next. Thanks for watching, and I'll see you in the next video.